I'm going to deliver a lecture on how to solve the problems, how to elucidate the structure using spectroscopic methods. Structure elucidation of organic compounds using spectroscopic methods. An organic compound is given to us whose molecular formula is C6H12O2. It shows the following IR data. We get bands at 2950, 2850, 1730, 1480, 1460 and 1400 centimeter inverse. These are the bands which we obtained in IR spectra. And when its proton NMR is recorded, we get following peaks. At delta 1.20, we have singlet due to 9 protons. We also get a singlet at 3.70 due to 3 protons. We are to solve the structure. We know the molecular formula of compound is C6H12O2. We can calculate DBE, double bond equivalence. We know the formula. Six plus 1 minus 12 by 2, and this comes out to be 1. So the molecule either contains C double bond C or C double bond O or one ring. If we see the IR spectra, the bands at 2950 and 2850. These two bands indicate the presence of methyl group, and band at 1730 centimeter inverse, again this tells that ester group is present. If we see the NMR, singlet at delta 1.20, which is equivalent to 9 protons, This indicates that 9 protons, they are in same environment because they are giving a singlet. So that means tertiary butyl group is there. Now another singlet at delta 3.70 equivalent to 3 protons. This indicates ester methyl group. So the possible structure of given compound is this. So this is how structure is solved. Next problem is a colorless liquid of molecular formula C4H8O shows the following spectral data. This is the second problem. An organic compound which is in the liquid form and is colorless and have molecular formula C4H8O. This shows the following spectral data. In IR, we get a band at 1715 centimeter inverse, and in NMR at delta 1.06 we get a triplet due to 3 protons and a singlet at 2.14 due to 3 protons, and we get a quartet at 2.43 delta. This is due to 2 protons and this is quartet. Now if we see the spectral data, the band at 1715, this indicates compound contains a carbonyl group, and molecular formula, this suggests that compound is either an aliphatic aldehyde or ketone, because if it is aromatic, at least 6 carbons will be there. So this is aliphatic aldehyde or ketone. So first information is given by IR by the peak band at 1715 centimeter inverse, that it is carbonyl, it may be aldehyde or it may be ketone, and this aldehyde or ketone is aliphatic because molecular formula is C4H8O. Now if we see the NMR, this completely eliminates the presence of aldehyde group because we do not get any peak near delta 9.5, which appears if this proton is present. So this possibility is ruled out. No aldehyde is there. And it confirms the presence of ketone. Now, at delta 1.06, we get a triplet. Delta 1.06 triplet. This is due to these three protons. Then we get a singlet due to three protons at delta 2.14. This is singlet. And then at delta 2.43, we get a quartet. Because these two protons are being splitted by these three protons on the adjacent carbon. A protons are splitting the signal due to C proton into a quartet. So this is the structure which we solved on the basis of IR and NMR. Now third problem is an organic compound is given to us which is colorless liquid. Molecular formula is C9H10O2. And in IR we get bands at 1720, 1602, 1581, 1270, 1105, and in NMR we get a triplet at 1.29 due to three protons. Then we get a quartet at 4.35 due to two protons. Then we get a multiplet at 7.40 due to three proton. Then we get a multiplet at 8.81 multiplet due to two protons. We are to determine the structure of this compound. Now, first of all, if we see the IR, carbonyl absorption at 1720 in conjunction with the bands at 1270 and 1105 centimeter inverse are showing the aromatic ester, and the bands at 1602 and 1581 confirms the presence of an aromatic ring. So IR is beautifully explaining. Benzene ring is there. Band at 1602 and 1581. These are the bands due to this group. And band at 1720 carbonyl group, and band at 1270 and 1105 is due to this CO. So IR is giving this information. Now we are to relate it with NMR data. Triplet at delta 1.29 is due to 3 protons. And the quartet at 4.35 due to 2 proton is due to these CH2 protons. This indicates the presence of this moiety. That means these 3 protons are splitting the signal due to these 2 protons into quartet, and these 2 protons are converting this signal into triplet. Here we are getting triplet and here we are getting quartet. And in the aromatic region we get 2 types of protons. Two separate downfield multiplets which are located at 7.40 and 8.81. These shows the aromatic protons B and C. 3 protons are of one type, HB 3 protons and HC 2 protons. Orthoprotons C are de-shielded by the diamagnetic and isotropic effect of C double bond O. So the downfield signal is obtained by C type of protons. So due to C protons we get signal at 8.81. 8,1 delta. And the upfield multiplet, this indicates the presence of these B protons, which are 3 in number, and we obtain signal at 7.42. So in case of aromatic protons, there are total 5 protons. 2 are of one type, 3 are of another type. 2 are downfield, which are near the C double bond O. D shielding effect is there. So they appear downfield, and B type of protons, they appear somewhat upfield at 7.40. So this is the structure of the compound. Thank you.